This is the City of Idaho Falls Erosion and Sediment Control Plan Designer Training class. My name is Angie Gilman, and my company is called Engineering with a Mission. My colleague, Adam Lyman, with Simon Company, and I have put together this training for you. Our agenda for this class is to briefly cover the history of the EPA's Clean Water Act and the National Pollution Discharge Elimination System. We'll talk about the City of Idaho Falls and their responsibility as it pertains to the Clean Water Act. We'll go over the EPA's Construction General Permit briefly. We'll talk about erosion control BMPs, sediment control BMPs, various other BMPs, final stabilization. We'll look at a plan designer checklist that you can use, and we'll do a quick plan preparation activity. Our goal for today's class is to give you tools to design effective and thorough erosion and sediment control plans for your projects in the City of Idaho Falls. So why are you here today? The EPA created the Clean Water Act in part to make sure that our rivers and lakes are fishable and swimmable. Seems like a good idea, doesn't it? The picture on the right is of the Cuyahoga River in Ohio when it caught on fire in 1969. This helped spur action that ultimately led to the passage of the Clean Water Act in 1972. The City of Idaho Falls is required to do their part to minimize polluting of stormwater that discharges to the Snake River. Part of what the EPA requires is that the city have an ordinance that pertains to erosion and sediment control, and to enforce those ordinances by inspection. The city doesn't have an option but to abide by the EPA's conditions as they pertain to construction. Failure to meet these requirements by the city is a violation of federal law. So why is water quality important? When sediment load increases in a river, the water temperature increases. As that water temperature increases, aquatic plants die, aquatic insects decrease, leaving less food for fish. And high temperatures also mean that certain species of fish can no longer thrive or survive. It also makes recreation less enjoyable. So what does this have to do with you? Well, construction is the leading cause of sediment runoff in urban areas. The National Pollution Discharge Elimination System is under the EPA's Clean Water Act. The NPDES is over stormwater management for the following three sectors: construction, industrial or multi-sector, and municipal. Municipal pertains to the cities that discharge stormwater to waters of the U.S., such as Idaho Falls. When you're working in Idaho Falls, you are complying with their requirements with the EPA as it pertains to stormwater management. Your project may also come under the Construction General Permit if it meets a certain set of criteria. We'll talk about that a little bit later in class. The purpose of the City of Idaho Falls Erosion Control Ordinance is to protect stormwater, groundwater, water bodies, water courses, and wetlands from construction activities pursuant to and consistent with the United States Clean Water Act. Their goal is to manage and control the amount of pollutants in stormwater discharges, soil erosion, sediment discharges, mud and dirt deposits on public roads caused by or the result of construction activities. The Idaho Department of Environmental Quality has jurisdiction over air quality for the entire state of Idaho. That includes regulating fugitive dust on construction sites. The Idaho State Rule requires that all reasonable precautions be taken to prevent particulate matter from becoming airborne. That includes dust from job sites. If a contractor is not doing his part to contain dust on his site, the Idaho Department of Environmental Quality should be contacted. There are consequences for noncompliance. Failure to reasonably control fugitive dust can result in enforcement action, including monetary penalties. As we mentioned before, the EPA's Clean Water Act includes coverage over stormwater from construction activities through the Construction General Permit. The EPA's coverage through the Construction General Permit is for any construction project that disturbs more than 1 acre or more. It also applies to smaller projects that are part of a larger common plan of development. An example of a larger common plan of development would be a subdivision. The Construction General Permit is applicable inside as well as outside the city limits. If your project does fall under the requirements of the EPA's Construction General Permit, you'll need to go to the EPA's website and look under SWIP or Stormwater Pollution Prevention Plan Tools. There are templates that you can use, as well as example SWIP plans and guides for you to use in preparing your SWIP for your project. Here's some important things you need to know. Your SWIP must be developed prior to submitting a Notice of Intent, or NOI, for coverage on the EPA's website. The contents of your SWIP will include the sequence and estimated dates of your construction activities. It'll include a site map or site plan showing where your BMPs are and describing them. You'll have a description of your stormwater controls. You'll need to document your pollution prevention procedures. And you'll need to document your procedures for inspections, maintenance, and corrective actions if needed for your BMPs that you're going to install on your project. Corrective actions refers to any sort of repairs to a BMP that are beyond normal maintenance. Self-inspection is required if your project has coverage under the Construction General Permit. Self-inspection is required once every 7 days or once every 14 days and after a 1/4 inch of rain event. The frequency increases if your project discharges to waters of the U.S. The frequency increases to once every 7 days and within 24 hours of a 1/4 inch of rain event. If you are discharging to waters of the U.S. on your project, you'll need to do turbidity monitoring in addition to your self-inspections. Refer to the Construction General Permit document for the requirements for turbidity monitoring. The EPA's Construction General Permit is updated approximately every 5 years. The last update was in 2017. New to the 2017 CGP is an explicit prohibition of non-stormwater discharge of external building washdown waters that contain hazardous substances such as paint or caulk that contains PCBs. Another change to the 2017 Construction General Permit is that construction operators must post a sign or other notice of permit coverage at a safe, publicly accessible location in close proximity to the construction site. This notice must also include information informing the public on how to contact the EPA to obtain a copy of the SWIP for the project and how to contact the EPA if stormwater pollution is observed in the discharge. Your SWIP document will need to include instructions to the contractor about this. Okay, we've completed talking about the federal, state, and local requirements. Now we're going to go ahead and talk about the best management practices that you're going to need to incorporate on your project. So just what are BMPs, or best management practices? BMPs are the methods, measures, or practices used to prevent or reduce water pollution, including but not limited to structural and non-structural controls, operation and maintenance procedures, other requirements, scheduling, and the distribution of your construction activities. The different classes of BMPs include erosion control, sediment control, run-on and run-off control, housekeeping and materials management, planning and project management, and post-construction BMPs. So before we talk about them, let's talk about why we need BMPs. Erosion control is our first line of defense. If we can keep soil from moving in the first place, then we don't have to clean it up someplace else. Our goal is to prevent water from running across our exposed slopes and surfaces as much as possible, and to try and keep soil in place. If we don't have erosion, then we don't have to clean up sediment someplace else. This is a case of an ounce of prevention being worth a pound of cure. So what factors influence erosion? Soil erodibility is a huge one. Silts and fine sands are very erodible, and we have a lot of them in Idaho, whereas clays and heavy gravels are not as erodible. Vegetative cover is another big one. Good vegetative cover provides protection from erosion through roots holding the soil in place, as well as the plants themselves protecting the soil from raindrop erosion. Plants also slow down the velocity of water as it flows over the ground. Reducing the velocity limits how much power the water has to pick up soil particles. Topography is an obvious one. The flatter, the shorter the slope is, the less likely it is to see significant erosion, where longer, steeper ones are much more vulnerable. Climate determines how much precipitation a project site will see. Areas with high annual rainfall are much more susceptible to erosion than arid regions. And finally, season. Regardless of where your project is, constructing it during winter months will definitely impact how much erosion you will need to account for during your project. Now we're going to cover the erosion controls that you might use on your project. The first one will be preserving vegetation. We'll go over slope tracking and slope roughening. We'll talk about mats and blankets and mulching. The number one thing a contractor can do to minimize erosion is preserve existing vegetation. Preserving vegetation is a free BMP. It slows down the velocity of the water, the roots help hold the soil in place, and it also reduces raindrop erosion. So encourage your contractors to minimize disturbing existing vegetation. Encourage contractors to provide positive protection for areas they want to keep undisturbed. Use construction fence to keep areas from being tracked over, reducing your sediment runoff from construction activities. Next is slope tracking or soil roughening. The purpose of this is to hold the soil in place by firming it down. It also helps trap the seeds in the little grooves that are created from the tracks. Also, the roughening from the tracks reduces the flow velocity of the water as it runs over it. Some of the maintenance issues to consider are making sure that you do your slope roughening when you know that there isn't rain in the forecast. Additionally, it's really critical that the soil roughening or the tracking be done up and down the slope and not parallel to the slope. Mats and blankets are another erosion control BMP. The purpose of the mats and blankets is to do temporary stabilization of your slopes. They help to establish vegetation by protecting the seeds as they germinate. They also come in a variety of types, thicknesses, and specifications. Some erosion control mats and blankets are meant to last for 12 months, while others are intended to last up to 3 years. So make sure you get the blanket that's appropriate for your intended use. The key to mats and blankets being effective is proper installation. Seed beds need to be prepared prior to the mats being installed. The mats must be installed from the top down the slope. The mats need to be staked in well all along the slope, and the mats need to be overlapped sufficiently so that there aren't gaps between them. And the most critical is that the mats need to have a really good contact with the soil. So the slopes need to be graded prior to the mats being placed. If there are holes or large lumps in the slopes, then the mats, wherever those are, is where soil erosion will take place. Mulching is generally effective for slopes that are steeper than 3 to 1. It's really important that you apply the appropriate amount of mulch and tackifier. More mulch might be required on steeper slopes, while flatter slopes may not need as much mulch. Sediment control BMPs include stabilizing your construction entrance, fiber rolls and straw wattles, silt fence, check dams, and inlet and outlet protection. Relative to erosion control BMPs, sediment control BMPs are generally about 50% effective. Erosion control BMPs are more likely to be 90% effective. Therefore, erosion control BMPs should be your first line of defense. A stabilized construction entrance is non-negotiable. It must be required. Make sure that the rock is 2 to 4 inch clean, crushed rock. Round river rock is not acceptable. The depth needs to be approximately 6 inches thick. The width needs to be 20 feet and the length 50 feet. And it needs to be replenished if the rock gets filled with mud. As you're doing your inspections, make sure that these dimensions have been met and let the contractor know if the rock gets too dirty and needs to be replenished. According to the EPA's requirements, track out must be swept the same day. So encourage your contractors to minimize track out, and if it does happen, to clean it up the day that it does. Fiber rolls or straw wattles are an extremely versatile tool for sediment control. Their primary function is to slow down water and to trap sediment. They can be used for perimeter control, as shown in this picture. They can also be used along the toe of hillsides, as well as along contours of hillsides. Again, always make sure that you install fiber rolls along the contour. Make sure you overlap them sufficiently at the ends where they meet. Make sure you have very good contact with the soil for the entire length of the roll, and make sure that it's staked down properly, typically every 4 feet. Maintenance issues associated with fiber rolls and straw wattles include the fact that they're not very durable. They will need to be replaced if they get broken. Additionally, you'll need to muck out any sediment buildup on the back side of them if there's a storm event. Fiber rolls are very useful, but their uses are limited. It's generally not very good to use them as inlet protection because they're light and they can float. They can be used as check dams for limited situations, but because they are fragile, they will deteriorate quickly. Silt fence is probably one of the most common sediment control BMPs used. Silt fence works by ponding water and allowing sediment to settle out. Silt fence is good for use at the bottom of large exposed slopes, as well as as a barrier around the bottom of stockpiles. Silt fence should never be used in high concentrated flows. It is intended to pond water. Silt fence is absolutely useless if it's installed improperly. It must be trenched in as shown in this diagram to the right. The stakes have to be installed on the downhill side. Additionally, it must be maintained. As sediment builds up behind it, it must be cleaned out in order for it to continue to be effective. It's also really important that silt fence be installed at the same elevation or the same contour line. Installing it up and down a hill is absolutely useless. So take a look at the picture here on the right. What's wrong with this picture? If you were the inspector on this site, how would you direct someone to fix it? Well, there's a number of things. First, the silt fence is installed, at least in part, up and down the hill, which is completely useless. Additionally, it's only being installed at the toe of the slope, and there's no other BMPs further up the hill to slow down the velocity of the water or to impede any kind of runoff. On the left, about halfway up the picture, it looks like someone's tried to use the silt fence as a couple of check dams. This is the wrong application for silt fence. Silt fence is not intended to be used in concentrated flows. Check dams are an excellent sediment control BMP to be used in ditches and swales. The primary purpose of check dams is to slow down the velocity of the water while ponding the sediment behind the check dams. Again, proper installation is key for the effectiveness of check dams. The elevation of the toe of the upstream check dams need to match the elevation of the top of the downstream check dam. Also, the center of the check dam needs to be lower than the sides. Otherwise, water will quickly find a path along the sides and erode them. picture on the right shows straw wattle being used as a check dam. Because they're not very tall, they're only going to work in fairly flat conditions. Also, because they aren't very durable, they shouldn't be expected to last for a very long time. Inlet protection devices are the last chance to stop sediment before it goes into the storm drain system and enters the Snake River. Again, the primary purpose of this BMP is to slow down the velocity of the water and settle out sediment. A variety of options are available for inlet protection, including coconut fiber mats, similar to the one shown up in the right-hand corner, rock-filled bags, as shown on the bottom right, and inlet devices, as shown below. Inlet and outlet protection is another important sediment control BMP. Again, the primary function, as similar to other BMPs, is to slow down the velocity of the water and to let the sediment settle out. Use clean, angular rock for your riprap. Make sure that it's wide enough to collect all of the sediment that it needs to. The length will depend on the slope and the soil conditions. If you do see the potential for run-on or runoff, consider diverting flows so that they go around your site rather than through it and picking up sediment. Also, install some sort of device such as straw wattles or a berm to keep water from running off your site, reducing sediment loss. Now we're going to move on to our next class of BMPs, which is housekeeping or materials management. This group includes debris containment, dust management, storage and proper disposal of toxic materials, and stockpile management. Debris management is a big part of keeping a job site clean. Check to see whether or not the site has a debris container. Check to see that the size of that container is adequate for the project. If there's garbage overflowing, let the contractor know that he needs to have it regularly serviced. The new construction general permit states that all debris containers will be covered when not in use. This may not be practical all the time, but the contractor should have a way of covering his debris container if it's needed. Dust management is really critical for our job sites. Why is dust regulated? We have a lot of very fine silt particles in Idaho. Those silt particles are comprised of silica or glass. So the dust in our air is basically fine, tiny, sharp pieces of glass, which is extremely hazardous. As those fine particles are inhaled, they penetrate deep into lungs, causing lung diseases. They can affect people with impaired lungs as well. Not only is it a health risk, but it's also an air quality issue, and it's a nuisance. Make sure you specifically mention dust management when you're preparing your erosion and sediment control plan. Storage and proper disposal of toxic materials is often overlooked on job sites. If you see on a job site that there are toxic materials, let the contractor know that they need to be stored in a leak-proof container. Oil is considered a toxic material and needs to be stored properly. If a vehicle does require maintenance, make sure that the contractor uses drip pans or some sort of pads underneath the equipment while the maintenance is taking place. If there is some sort of a spill on site, direct them to clean it up immediately and dispose of that material properly. Concrete washout is extremely toxic to any kind of aquatic plants or animals. Concrete washout must be stored in a leak-proof container. This can be as simple as digging a pit and lining it with visqueen and surrounding that with bales. When you're doing your inspections, make sure that the concrete washout is lined. It also needs to be signed very clearly so that subcontractors will use it. When you're putting your erosion and sediment control plan together, make sure you designate a spot for concrete washout and show a sign for the concrete washout so that it's clearly marked and visible. During your inspections, make sure you check to see that the porta potty is staked down to protect it, and make sure it's not placed anywhere near a curb and gutter or storm drain inlet. Check to make sure that the contractor has a spill kit on site, as that is required by the EPA's Construction General Permit. Encourage the contractor to avoid fueling and maintaining vehicles on site if at all possible. Also remind them that they need to sweep their construction entrance daily to make sure that track out is not an issue. Let your contractor know that illicit or illegal discharges are a big thing to the Environmental Protection Agency. An illicit discharge is defined as any discharge to the MS4 or storm drain system that is not composed entirely of stormwater, except for those discharges that are allowed under an EPA permit. Allowed discharges are limited to fire hydrant flushing, landscape irrigation, wash water that doesn't contain any kind of soap or solvents or detergents, water used for dust control, and water used for flushing water lines. Next is stockpile management. If a stockpile is going to be sitting unused for 14 days, it must be stabilized. That can be done through a variety of methods, either covering it with a tarp, mulching it, putting on temporary seating, applying straw and a tackifier. There's a lot of possibilities. But again, the critical thing is that it be stabilized if it's going to sit unused for more than 14 days. For dust control purposes, the top of the stockpiles should be flattened. When construction is getting ready to start on a project, talk with the contractor about how to phase the project to minimize exposed soils. Also, if there's going to be dewatering during the project, make sure that that dewatering plan is included with the erosion and sediment control documents approved by the city. If it was unknown at the time of the start of the project and it's suddenly becomes an issue during construction, have the contractor stop and submit a dewatering plan for review and approval before they start work. If the contractor is going to be dewatering into any kind of surface water, such as a Snake River or any other surface water, make sure they understand the requirements of the construction general permit. Turbidity monitoring is required by that construction general permit if dewatering to surface water is going to be done. If you're not comfortable with preparing a dewatering plan on your own, find someone who is familiar with it to assist you. Make sure the contractor understands that they can't start dewatering until the dewatering plan has been approved by the city and as well as the EPA if you fall under the construction general permit guidelines. Okay, we're down to post-construction BMPs. Post-construction BMPs include anything that stabilizes a site on a permanent basis. This can include anything that covers bare soil, such as asphalt, concrete, buildings, and landscaping. There can be no bare soil on your site once construction is complete. Per the construction general permit, contractor must achieve 70% revegetation on a site in order for it to be considered stable. So make sure that you provide post-construction BMPs to make sure that that's attainable. Remind your contractor during the construction project that one of the best BMPs they can use is achieving final stabilization through revegetation. Encourage them to seed or sod any of the areas that have been final graded. Once you get to the end of the project, make sure that they understand that 70% revegetation requirement. The other option is to have them use temporary erosion control measures along with seed to achieve that 70% coverage. Temporary erosion control measures can include straw blankets or mats and wattles, and also placing a tackifier and mulch over that seed. Your role as a plan designer is a big one, as the contractor is going to be looking at your plan to minimize sediment during construction as well as after construction. One of the best things you can do is start by performing a site assessment. Look for potential locations for runoff onto your site, as well as places where water could discharge off of your site. Identify surface waters within the vicinity of the project. Look at locations of discharge and any kind of proximity to waters of the U.S., even storm drains, as often they go directly to rivers and lakes. Evaluate your site for types of temporary BMPs that you're going to need. Consider final stabilization measures that you're going to need to use given your soil conditions, topography, weather, etc. Look at where the best location will be for that construction entrance. Locate your staging area, potential stockpile and laydown areas too, understanding that the contractor may choose to move them if necessary. And then also look and see if there's any other potential impacts to erosion and sediment control, such as possibly a neighboring job site, or maybe agricultural ground that's near you. Identify sources of pollution associated with the specific project that you've designed. What are the potential contaminants from this work? Do you have paint, drywall, concrete, stucco, solvents? Identify pollution controls that you're going to need to use given those sources. Will dewatering be performed? Where will potential pollutants be stored? Are containment areas needed? And where will a spill kit be located for this project? As a plan designer, some additional responsibilities will involve project administration, such as documenting the project estimated start and end dates, documenting any sort of phasing that will take place during the construction. Also, if the project is covered under the construction general permit, you'll need to identify who will be responsible for submitting the notice of intent to the EPA, performing some inspections, and maintaining the BMPs. You'll need to outline the inspection schedule and how rainfall will be tracked. Identify seasonal windows for establishing vegetation, and identifying if there are any additional permits that affect the plan or the project. Here's an example of an erosion control plan preparation checklist that you could use when preparing a plan for the city of Idaho Falls. Here's a list of some of the core BMPs that you'll want to make sure that you include on your project. Here's a very simple example of an erosion and sediment control plan. The note outlined in blue in the center is referring to the storm drain inlet being protected by gravel-filled bags. The note and arrow outlined in red are the construction entrance. The note outlined in orange is the concrete washout being identified. And the note outlined in yellow refers to the storm drain swale that's being constructed at the beginning of the project so that it can collect sediment during construction. The purple line along the south and west fence is where the straw wattle is being placed, as that's the general direction of the flow at this site. This slide shows an example of notes that could be used for an erosion and sediment control plan. The first section of the notes is the project description, including the estimated construction dates, type of work being done. The second section is the existing and modified conditions, what the existing site looks like, and what the modified site will look like once the project is done. The next section is the owner or the responsible person's contact information. And finally, the section to the right are the BMPs proposed in addition to the ones shown on the plan sheet on the previous slide. The notes include where the site access will be, discusses waste disposal, minimizing the disturbance during construction, graveling the entrance and sweeping at least once a day, locating where the concrete washout will be, stating where the straw wattle will be located to minimize sedimentation, and that the erosion sediment control plan will be on site at all times, and a sign will be placed at the project listing who the responsible person is. The final notes discuss where vehicles will be located, where materials will be stored, and what final stabilization for the project will consist of. That's the end of your training for this Plan Designer class. In summary, we went over the history of the EPA and the Clean Water Act as it pertains to construction. We talked about the City of Idaho Falls and their responsibility with regard to the EPA's Clean Water Act. We touched briefly on the EPA's construction general permit. We went through some erosion control BMPs and some sediment control BMPs and other BMPs that you'll need to consider for your projects, including final stabilization. We looked at a brief checklist that you could use when you're putting together your plans, and we went through a quick example of an erosion and sediment control plan and notes. I hope this presentation is giving you some tools for you to use as you put together your erosion and sediment control plans for the City of Idaho Falls. Thank you.